So, welcome to the Fusion 360 tutorial for the Manufacturers Podcast. Today, we're going to go over the Fusion 360 interface and the tabs and also the workspaces. So, I have Fusion 360 open here, but what you'll want to do to get going with Fusion is we'll go to autodesk.com. Okay, I'm already signed in here. But what you'll do, you'll go to Autodesk and you'll want to create an account. Okay, so you'll create an account. I guess I was not signed in, but we'll do that now. So you'll create an account and then you'll see they have different products. So if we scroll down, we'll find Fusion 360. You can see here, this is the price for the full access version. You can pay by the month or the year or 3 years, whatever you want. Let's just select Fusion here. Now, we'll forget the paid version. You can get a free trial. And if you're a hobby user, you'll see it shows you download Fusion 360 for personal hobby use. It's a free limited license, and it'll go to explain, what you have. Now, if you want the full license, you can get a 30-day trial. Then you'd have to purchase it. But for hobby, for uses, and what you would most likely want to use for additive manufacturing and for your 3D printing, is right here. You'll have all the functionality you would really need for that. The only thing you're not going to have access to is some of the simulation, the generative design, and the exporting of certain files and whatnot. So you'll download this. It might take a minute, but you'll download Fusion. So once you have Fusion downloaded, so you can see our layout. This is our user interface. Okay, so at the top, kind of standard to what you would find on a lot of Windows or Mac Pro softwares. You have your standard like file tab, your save. So Fusion is a cloud-based software. So the first thing you'll see is this data panel. So if we open this up, okay, what you will see is all the projects that you have. Now, when you first download it, you won't have any. And you have a home key. So you click on this, all your projects and the folders you set up. Now in Fusion, in this part, you will see there's some libraries. We have samples. They include tutorials. These will kind of help you go through what is available. There's also models. So if we go to CAM samples, we go into work holding. So if we go to like Lang, which is a popular device, in here you'll have models of their devices. So there's some things available to you. This would be more for setting up CAM in the manufacturer workspace. But we won't open any of this right now. I just want to explain to you the data panel. This is where all your projects will be saved. On the cloud, you can export them or save them locally as well. Then moving on, we have our file tab. This is very similar to any other program you've seen, like even Microsoft Word and Excel. So here, we can create new designs, templates, drawings. We can save, export, 3D print. This will get us to our output. We can screenshot, share, and whatnot. Now there's a quick tab. It's default. There are preferences that we can change, but for default and basic means, that is your top left interface. Now we go to the top right and we'll see some other things. So this has to do with your account. So you'll see it'll show if you're logged in. You have your help tab, notification center. You'll get occasionally things here. You have your job status. They'll show you if you're working online or offline. These are your extensions. So basically add-ins, things you can bring in. And if you see, all of these some of them will require separate access. Some of them are on a trial basis. This plus sign, that's a way to add a new tab so you can have multiple models open at once. So now focusing on the main part of the user interface for Fusion 360, you'll see in the upper left, we have this what we call Workspace tab. And as mentioned earlier, the workspace is essentially the environment or the screen you see in front of you. And we're currently in the design workspace. If we click on this and drop down the box, we'll see that there's generative design. Now, this is reserved for a paid license. You won't have this with an educational license, which is what we're using now. You have a render workspace, so we can create more realistic, lifelike, aesthetically pleasing appearances. We can get real life representations of our part. We can apply finishes and lighting and whatnot too. Then we have the animation workspace. This is similar to a motion study you would see in SolidWorks. We can add motion, we can add exploded views, we can kind of build a animated video if you're trying to give a presentation where you want to see how things work together. The next workspace is simulation. Now, I do not believe you'll have access to this on a hobby license. But in the simulation workspace, it's our FEA, which is finite element analysis. We can bring our models and parts in, and we can apply different types of simulations to them. So I'll show you for purposes here. We have load analysis, we have thermal stress, buckling, shape optimization, injection mold simulation, which will give us like flow analysis. So that's something we'll just get into these in further modules. But for now, we'll just go over them briefly. The next big workspace is for manufacture. So this would be for outputting CNC programs for milling, turning, as well as 3D printing. So you can see when we open the manufacturer workspace, we have different tabs, different options that come across. And if you notice with each workspace that we open, these selections in the tabs will change. They're specific to that workspace. So we have milling, turning, additive, inspection, fabrication, and then our utilities. The final workspace is drawing. Once we have a 3D model or an object created, we can generate a 2D engineered drawing from that. So we'll move back to the design workspace. This will be where you spend most of your time. And now we won't get into a lot of sketching here. We may get some examples up, which will allow us to show and explain some of the other parts of the interface. So the one large thing here that we need to cover at the bottom is our timeline. Now, in something like SolidWorks, we would refer to it as a tree, and it generally is on the left-hand side. And that's because we can model parametrically. Now, in Fusion 360, we have the ability to go from parametric modeling to direct modeling, which, if you listen to one of our previous episodes, parametric modeling, we broke down what that means. And essentially, the further we go into that modeling, that component, when we add features, they have relationships to others. So when we can go back in the timeline and we can make modifications, but that will affect what we have done. So in Fusion, it allows you to track that, and it will come across the bottom. Now, if we go into a direct modeling method, we will not have that design history. Direct modeling, like we mentioned, allows us to make changes, and it will not affect what has been done. So to give you a quick demonstration of how the timeline works, we'll create a sketch. So as you see across the top, when we're in the design workspace, we have solid, surface, mesh, sheet metal, plastic, which is a fairly new tab inside the design workspace, and then our utilities. In the solid, this first group, the create group, will be our sketching tools. If we drop this down, you'll see all the tools here. So when we're outside of a sketch, it shows all of our solid tools. Uh, Very similar to SolidWorks, we have solid tools such as extrude, revolve, loft, sweep. We can create holes and threads. There's some canned solid cycles, boxes, spheres, pipe, coil. We also have ways that we can translate. So pattern and mirror. The next group over is our modify group. This will be things that we can do to a solid once we've created one. So press pull. This will be able to offset a face in either direction. Essentially, if I had a square or a cube, a solid cube, and I click on a surface and I do a press pull, I can extend that surface in or out. Fillet and chamfer will add edge treatments, whether that be angular or with a radius. Our shell, that will allow us to hollow out an object given a wall thickness inside and out. Draft will allow us to add angle faces or tapers to a surface. Scale, as it may sound, we can scale up objects by a percentage or ratio. Combine, we'll do a Boolean operation, which Boolean essentially means it's similar to a combination. It will take two solids and merge them. Offset face, it's very similar to a press pull, but it can work on just one singular surface. Split body and split face, those are tools that we can use to, as they would say, split a solid. If we want to, make something such as a mold, and we want to cut it in half, by giving it a reference, it will then take one solid and make two bodies out of that solid. We have our move, copy, rotate. So this is our translation or transform function. This will allow us to do multiple types of translations. We can do incremental, we can rotate, we can copy a part, and we can move it, we can transform it linearly in any axis we choose. The next few selections down, this will apply to our properties. So we can apply a physical material, which then when we run any properties analysis, it will if we choose the correct material, it will give us a weight, an estimated weight. When we create drawings and assemblies, it will apply materials to a bill of the BOM, bill of material. It will apply an alloy or a material type. And when we're running simulations, it will also give us the correct data. In appearance, this allows us to colorize things. You can do that for realism, or we can do it to make contrast, to kind of organize groups of parts as well. So in the solids menu, the next group is our assemble. So once we have components, if we want to give them relationships to each other, that's how we would do it here. In SolidWorks, this will be referred to as mates. But in Fusion 360, we call them joints. We can assign joint origins from parts. That way they can be moved freely from one component to another, and it establishes a relationship. We can also add motion. We can connect parts together and give them animation as well. The next tab is construct, and this gives us our reference geometry. So mainly planes. planes and axes, uh, points. These are things that we can use to create sketches. And all of these things I'm going through, I'm kind of just touching on so you understand what they are and where they are and what each group is. And in the next series of videos as we progress, we'll be using a lot of these. In our inspect tab, this allows us to do a lot of like secondary analysis. So we can measure things such as points to point. We can measure lines. We can get cut sections. We can inspect a lot of things, center of mass, whatnot. This is kind of an advanced type of uh, tab or advanced type of function, but we will touch on it. The insert tab, this is kind of like a utilities menu in a way. This allows us to insert, as you would see, decal and canvas. So it'll allow us to bring in essentially like vectors, vector files, or lettering that we want to put. We don't have to create a sketch and draw lettering and extrude it. We can put face, surface decals on. Also, we can insert different files. So SVG, which is used like a vector graphic for decals or logos. A DXF, which is a two-dimensional sketch. We can take sketches and bring them in, and then from there we can create solids. We can insert McMaster car components. So for our assemblies, we can bring in hardware and different components that are pre-made from a manufacturer. And that will too cross over and include into our bill of materials. Fusion 360 also has an entire library of manufacturer parts. This can be anything from hydraulic cylinders to motors, lead screws, actuators, all kinds of mechanical parts for assemblies. And our final tab or group in this section is our select. Now this will give you different ways to select parts. We can we can click and drag windows, we can do lassos, we can mask. So just a way to select things. Sometimes we have multiple components or features and we only want to select certain ones. So now moving on in our interface, we have surface. So this is similar to solid, kind of the setup. But surfaces don't create actual thickened or 3D models. They will create a surface representation. So we can create a cube, but it won't have an interior. It'll be finitely thick. It'll be just a surface representation. This can be used for many things. If we want to mask something such as a hole or a cavity, we can do that. When you get into programming for CNC, like a milling machine, a lot of times we'll have holes and cavities and openings and pockets that we don't want the machine to cut material over. So we can apply a surface to that area, and then it gives us a boundary or geometry to avoid. You'll have the same various tools as you would in our solids. We're just creating a surface instead of a solid. Modify as well. Stitch basically will combine surfaces. We can trim surfaces, split them. Very similar to the solids menu. Once again, we're just creating a skin, so to speak. Assemble is the same. Construct. Everything else, all these other groups are the same in our surface. Now we come to our mesh tab. So mesh has to do with the way we represent a model. This comes into play with additive manufacturing, most relatively, and it's the way that it needs to be interpreted. Our solid, so it creates an array of triangulated areas or shapes that math can be done. So when we would slice a file, it'll be able to read those surfaces. and that's called tessellation. So it will basically apply this surface mesh or these triangles. So when we have a model, we have a solid model. We don't have to just convert it to an STL or a 3MF file. We can make it a mesh file on its own and then export it as. And there's some advantages to making something mesh without. When we convert a solid to an STL file, it will make the mesh. But here we can customize and refine the mesh and make it certain features that are very small or have curves. We can apply different density mesh to that, which will give us a better part overall. So we have create. So essentially we'll insert a mesh or we'll tessellate a solid. The prepare group, this will allow us to take several surfaces, whether that's flat or radial or axial surfaces, and we can create the groups, and this will allow us to be able to apply that mesh and the triangulation separately in different areas. So when we come to modify, this has a few tools that are similar to surface and solid. We have shell, we have combine, we have our transformations, we have a convert mesh. So we can actually take a mesh file and convert it into a solid. And remesh will take what we've done and it will kind of blend between the different surfaces. It will blend if we have a high density mesh on a curved surface and then a really low fidelity mesh on a flat surface. When we remesh it, it will make sure that that is translated and blended nicely so that there's no kind of irregular tessellation there. Then assemble, it's very similar. It has a few different options, but very similar to the solid and surface. Construct will be identical, inspect, and so on. Those are all the same. Now you will see here there's an export tab. This is then it drops down. It says 3D print. This is a way to take a mesh and put it right into a manufacturing file, whether that's 3MF or STL. So moving on, we have the sheet metal tab. Now, sheet metal is a little different than the solid or surface. So this allows us to create parts that have bend geometry, and there are tables or rules that we set up. So in sheet metal, you have things such as K-factor, bend reliefs, and you have to set those up pertaining to the material you're bending. So if you see here in the modify tab, we have sheet metal rules. So if you want to make a sheet metal part out of a specific thickness and you need a certain bend radius, we'll set that up. Because with sheet metal, we're ultimately going to be creating a flat pattern, and it needs that information to calculate the flat pattern. It uses what we call bend deductions or allowances. So we have to have a table of that information for it to work correctly. Similarly, to solid and surface, we will have a sketch tab. So we can create a basic geometry, and then we will turn it into a solid. And with sheet metal, there's your main component that you'll be doing are flanges. If you see the next tab over, it will say flange. So that can be a multitude of things. It will have angles and lengths and a radius. In sheet metal, those flanges will create the sides of a part. So if we're trying to make a box, we could draw any one side or to the dimension, and then from there, everything would be a flange. Now there are different types of flanges. We can create a mitered flange, which essentially we would take a 2D sketch and we would make a profile of multiple bends, and then from there it will generate those all in accordingly. So it's very simple. The way that you start sketch for sheet metal, but all those tools are there. We have the create flat pattern. So once we have a 3D model, it will generate a flat pattern with bend lines. In our modify tab, it has a few of the selections you would find in solids, like fillet and chamfer. Your materials, once again, your transformation tools. We have an unfold tool. So when we have a bent part, we can unfold a certain number of bends. We don't have to create an entire flat pattern. The assemble tab you'll see is very similar. Construct, inspect, insert, those will all be the same as the solid and surface menu. So here in our plastic, what we call the plastic tab, it allows us to create just a few different types of components that vary a little bit different from a solid. And it has some canned features in it. So in the create, we would still create a sketch just like we would. We have all our solid tools, our modification tools. With plastics, our first tab will be our setup. So very similar to sheet metal, we create rules, and we can have a library. We can assign rules to a certain part of the assembly. And then our modify tab, very similar to solids. We have a few less selections, but a lot of these you'll see they kind of repeat themselves. Assembles the same, construct, inspect. Now utilities. So utilities are, a lot of the things that assist us. So the first one you'll see is our 3D print utility that converts any mesh. You can take a solid, it will convert it to a mesh, or it will take a mesh and export it into a manufacturable file. We have a nesting tab that will basically allow us to create an array or take a certain number of parts or multitude of parts in a quantity and put them within a designated space. Our add-ins. So add-ins here, once again, we showed you they're like extensions. So we have different functions that we can use inside of Fusion 360. We'll go over this in another video, but there's a lot of functions and options that aren't defaulted, but we can bring in different analysis tools, vendor or manufacturer add-ons, and whatnot. As they upgrade Fusion, there's different functions and user-friendly things that come in. So once this utility, we have managed materials. We can have a materials library. We can recompute anything. So when you make changes and whatnot, we have our inspect tab. You'll find this on most of the other tabs. Our selection, and then now here what we see, this says exometry, instant quote. So this is an add-in or a script. This basically will take anything I've modeled, and exometry is a rapid prototyping company that you can insert parts online and it will give you instant quotes. It'll give you a price per quantity and features and whatnot. It's a very useful tool to have. Even if you're not going to buy the part from the company, it will kind of give you a rough price of what it should cost to manufacture that. So moving on, we don't have access to generative design, and that's kind of an advanced level. I do have access to this on another account. So in a future video, we will touch on that. Now render, since we don't have a part available here, this will be another module, most likely combined with animation. So just to show you, so we have our render workspace. So if we had a part made, we would bring it in here, and you know what? Let's make something real quick. So we're going to create a sketch. We'll just make a circle. Okay, we'll just make a simple little cylinder. Okay, and to give you a demonstration of what render will do, I'll apply a material and an appearance. So we'll pick a metal. We'll go with an aluminum. So let's say a 6000 series aluminum, which is very common. You'll see that the color of it actually changed here because now it has a material property. All right, so now if we go to render, all right, see this looks a little different. All right, we can see it, and if I move it, you'll see that there's a light, there's a shadow. So it actually creates a scene. So what we can do is we have our scene settings. We can actually put an environment, and there's different parts in this library. We can throw different things in here. See, I brought this in, which says Plaza. Now we have a little bit different lighting, so it kind of replicates lights, of what we would see. See, now I brought in cool light. So if we're trying to set up a display, so if you were trying to give a presentation and you wanted to show a component that was sitting on a kitchen table, you could actually have a decal or a background, a screenshot of a home, and then you could render a part and have it sitting there. Or if it's a car, you could have a background of a street or whatnot. We can also here we can change our physical material and appearance once again. We can add decals and whatnot. So being this is aluminum, it's going to have a certain shine to it, or a look. So we have our in-canvas render. So as you'll see, what it's doing now, if I hit render, it's going to go through. This takes a lot of computing power, so we probably won't run through it all right now. But you can let this run for a long time, and it will keep generating better and better and better and better and better appearances. So you could have something with a mirror finish, and you can get it so it'll almost look perfect or real life, like a real life object. So moving on, our animation. So we have this part. Now, if I wanted to capture it, I could create a storyboard. Normally, this would be for assemblies. We'd have multiple parts, and I can actually capture. I can make a recording. So if I had multiple parts, I could use the transform tab, select my tools. We can explode parts. We can do auto explode. We can kind of create. If you ever seen videos like companies have, they might have like an engine for a car, and then all the parts like get removed one by one. You can actually make that here. These are your recording tools. We'll have a video that touches on this, probably combined with a render. So our simulation. Now, there's a lot of setup that goes to simulation, and I'll just touch over the interface, but we won't really get into the study. So essentially you have a part, and we have to create. So we have our study, which we've done. We apply material properties. We have constraints, which we could fix a face, and we have loads, so we can actually apply if I wanted a force or a pressure, gravity, all this. A lot of this will probably save for further video, but we can actually run analysis on parts in here, which is very, very good to do. So if you design something that you're going to build, like if you're going to weld it, and you want to know if it's strong enough, you can actually, if you're making a bracket, you can simulate a certain amount of weight that would sit on it and know if it's going to crumble, like fold or buckle. Right. So our manufacturer workspace, we'll touch on this. This is very commonly used. So we have a part. Say we want to machine this. All right. So our first tab is setup, and setup is what we would use to basically create a work coordinate, or how we locate the part, our stock and whatnot. Now, if you're not familiar with CNC machining, subtractive manufacturing, then we have to, if we want to create this part, we have to start with a piece of material that's bigger. So this translucent area would represent stock, and we can make this bigger and bigger and bigger and whatever size we want, according to what we need. And our orientation, basically where our reference point is, we can set up that. So we have milling and turning. So difference between milling and turning is just specific to the process, the type of cuts that it will take. Once we have a setup done, now 2D and 3D are tabs. These are types of toolpaths. Now, we'll be doing a video just on cam, and we'll do a 2D cam and a 3D cam and then a multi-axis cam module. And we'll describe what these all are, but they're different types of toolpaths. 2D running in it, like it would seem, 2-axis. 3D can be a 3-axis, multi-axis movement. We can do drilling. Multi-axis, which is what we call 4 or 5-axis. We have an actions tab, which will generate our toolpath. We can regenerate our toolpath, which will process it. We can simulate the cuts. Post-process is how we generate our G code that we would send to a machine. And then we can do setup sheets, which are basically just like a data sheet that we'd apply to put with a part, so the operator would know what's going on and have all the information. Our manage tab, this will manage our tool library, machines, post processors, templates, all of the things that we're going to use in our setup. We have an inspect tab again and our select tab. So turning will be very similar. We have turning toolpaths here that are specific to lathes. Part handling, if we have multiple chucks, we have drilling once again, and then the same actions, manage, inspect, select tab. In our additive tab, we'll see in our groups, we have setup. So just like milling and turning, we have a setup we need to do. As you'll see, basically it'll ask us for, it's giving references, a machine type if we want, and whatnot. Our position. All right, so setup. So actions, we get similar to milling and turning, we can generate, simulate, post-process. Now what you see here says NetFab for Fusion 360. NetFab is a software by Autodesk that is exclusively for additive manufacturing. It's far more in depth than what you would see anything you could do here, and that will allow you to transform parts, to add supports, to process them, to set it up for the machine, do your slicing. And once again, we have a manage, inspect, and select. So tools, library, machine library, post-processing. Inspection. So this will be for metrology, such as CMM and probing. If you're going to use, we don't see it here. It used to be in the milling tab, but now in inspection. So if you have a probe on your milling machine, you can program that here to pick up work offsets, or as well as for metrology needs. You can create inspection reports, manuals. So we have probing for work coordinate, probe geometry, surface, and part alignment. We have our actions tab. There's a few more selections. They're specific. We can save reports and whatnot. So fabrication, this will be for like jet cutting and laser cutting. So different types of cutting process. So it can be for a oxyacetylene track torch, a plasma table, a laser cutter, a water jet, and what have you. It's basically creating a 2D profile that will have an offset, which is determined by like a curve, whatever type of process you're using. So we have a nest. Like I mentioned before, nesting, if we had a flat sheet of material, and we were cutting out a bunch of circles, we could nest them inside of a certain area, and it will give us, quantity or amount we need. It'll manipulate things and fit them in the best way possible. We have a setup tab or setup group, very similar to the milling, turning, and additive. Next is our cutting. So we have just a 2D profile. We have an actions tab once again. Our manage tab. This has a couple more selections, like we have material, process material, and packaging presets. There's some things that you can add to it. Inspect and select. Now in the manufacturing workspace, we have utilities once again. Very similar. A lot of it is already in the other areas. We can do a machine builder. We can actually bring a machine in if we have a model, and this will allow us to. Sometimes it's nice to have the machine and the work table and the work holding, and we can create a full simulation, so we can really, be able to see what's going on, and sometimes that helps us avoid any issues. So our last section, since we have a part, we can bring up a drawing just to kind of show you. So we're going to go in the drawing workspace from design. We can give it a name. Untitled is okay. Folder. It's going to say here what we want to do. We can create new. We'll choose our sheet size, the units, the standard we want to run. All right. And then it's going to basically give us a 2D engineered drawing. We can place our part. Now we can have our standard third angle projection. We have our, elevation view, our plan view, and our right side view. We can choose what kind of visibility we want, our scale, and whatnot. Now we do have the ability to make a custom template or modify the title block if you want to make it your own. Not a lot of people are going to do drawings unless you're making parts, for a company, or you want this part to be made, send it to a manufacturer or a machine shop. They're probably going to request a drawing. We'll have a video just on doing drawings and making custom templates and whatnot. Now, getting back so we have this part, and I mentioned earlier in design about our timeline and our parametric modeling. So as you can see down here in the bottom of this timeline, we have 3 objects now. We have, it'll tell us what it is. So we see sketch, component, and extrude. So, and then I have a slider here. So if I move this slider back 1, I have nothing. If I move it back again, I have nothing. So now you see in our tree here, we have our part. We have a settings tab, which we can change units. We have our views, our origin. So if I highlight this, you can see this is our Cartesian coordinate origin. And then right now I just have sketches. So you can see the sketch, and this eyeball, that's our visibility toggle. So if I toggle this on, because now in our timeline, what we have active is the sketch, I can see this sketch. Now, one thing you'll see, and how we actually move files around or move parts around, this is what it's referred to in some softwares as a gnomon. We can call it our axis cube. And you'll see it's a 3-dimensional cube, and it will have our X, Y, and Z. And then it has lettering on it that shows us what face we're looking at. Now, the one nice thing about Fusion is I can change this at any time. Our X, Y, and Z will remain the same. Now, this is I'm looking at the top. If I hit drop down this tab, I have snaps. I can go home. I can do a perspective view, orthographic. I can set current view as home. I can reset the home. Now, this uh, set current view. So if I select this, I can make this now the front. So now this would be the front. This would be the elevation view. Now our traditional uh, orientation, our X, Y, and Z, you know, in third angle projection right now, this would be our front view. So now this would be how we would correctly see it. X-axis, Y-axis, Z-axis. Now, so in this timeline, just to demonstrate what the timeline is, if I slide it forward, see now we have active as component, and I will see this component 1, and if we highlight and click once, we can change the name and assign a name to it. So now we call it circle. And we'll see we have origin. Now this will apply for any component, but still we have no solid, because once we had our sketch, we created a new component into a solid. Once we slide that ahead, that timeline, we now see our solid. Now, at any point in this, I can do a suppress, so it will hide it, or I can unsuppress. If we right click, we'll see this brings up a history menu. See, we can roll our. If I right click on this component, I can roll marker here. It does the same thing as if I slide that. Now, because we have a history and we're in parametric, if I want to make a direct modeling, if I want to change something to a direct model at that point, I can right click and convert to a direct model feature. I can also edit the profile sketch. So the sketch that is associated with that solid, I can edit it as well. What you will see here in the interface in the center is some of our selection and visibility tools. So we have orbit. So when we orbit here, we can click and we can pan around by holding on the mouse. We can look at a specific feature. So if I click this, if we have a lot of surfaces and I want to see one thing in particular, I can click look at. I can select this and it will snap to that feature. We have a pan, which basically allows us to move around in an orthographic manner. A free move, but won't rotate our axis. We have zoom, so we can zoom in and out. We can use the wheel and our mouse. We can also, when we highlight zoom, we'll see this arrow. If I click and hold and I slide it down, it gets bigger. Up, it gets smaller. We have zoom window. We can zoom to fit. It will fit it inside of our work area. Display settings. This will show us, we can pick wireframe, shaded with hidden edges, whatnot. It gives us different abilities. So we can look at mesh. We can change our environment. See, if I have really bright parts, I can change that. It gives us a little flexibility on how we display. Effects. We can turn off shadowing and ground planes and all this stuff. Our camera, we can change our perspective, our visibility, what we want to show. So if I have this deselect any of this, those will not show up, regardless what they are toggled at in the tree. We have snaps, so we can snap to grid, or we can do incremental moves. A lot of this I leave default. We won't really get into a lot of this. It's the default settings work very great. So for the interface, we've touched on just about everything. We do have another this gear, this setting here. This kind of has to do with our timeline. So we can say do not capture design history, which essentially reverts us into a direct modeling workspace. Once we have done something, made a part, you'll see that now we have an undo. We have all of our timeline features here. can also hide this, and we can expand it. You'll see here we can make comments. Um, that'll be here. I can make comments about and take screenshots and apply it to different things, so we can save that for future reference. Now the next so that's about wraps it up for this module. What we will do, the next module will come out hopefully in a week, and we'll get right into sketching, and we'll talk about sketches, we'll talk about bodies and components. We'll basically work in the solids tab, and we'll go through all the groups in that. We'll create some simple 3D parts. We'll show you how to model using the basic tools. It'll start out very simple and easy to learn. The fundamental here and the foundation was understanding what we're using, our user interface, what we have available to us in Fusion 360, how to navigate. Without that, we'd kind of be stumbling through. So now that you have an idea of the functions and tools that are available to you, the workspaces, what is inside of them, when we go through each individual module, when we do sketches and solids and start to do some other things, you'll have seen that before. It won't be new, and you'll pick it up very easy. So I hope you've enjoyed this. I hope it's informative, and I hope it helps you get a start using Fusion 360. Thank you.